These notes are on testing for parallelograms. So this question is asking, what are the 5 characteristics of a parallelogram? So the 5 characteristics that we've learned of a parallelogram are right here. First one, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and diagonals bisect, as well as consecutive angles are supplementary. These are the 5 characteristics that we've learned for parallelograms. So make sure you have these copied down. Now, what this page is saying is that if you have a quadrilateral, a 4-sided shape, you automatically know that it's a parallelogram if one of these is true. So if we know that both pairs of opposite sides are congruent, then we know that it's a parallelogram. If we know that both pairs of opposite angles are congruent, we also know that it's a parallelogram. If the diagonals bisect each other, that's showing that it's a parallelogram. And then the one that's starred in blue here, if you only have one pair of opposite sides that's both parallel and congruent, so if they're both congruent and parallel, so let me show you a shape, a picture here. Okay, so if I know that this is congruent to this, and I also know that this is parallel to this, notice both aren't marked on this side. But what the theorem is stating is that if you have one pair of sides that is both congruent and parallel, you know it's a parallelogram, just based on that. Now this is really important. One set of consecutive angles, like you can see here, does not necessarily prove a parallelogram. So when you're trying to decide if something is a parallelogram or not, you cannot say yes, it's a parallelogram because consecutive angles are supplementary. That does not make it a parallelogram. You cannot use it to determine if it's a parallelogram or not. So even though these are consecutive angles that are supplementary, that does not make this a parallelogram. In this picture, is this a parallelogram? Yes or no? So this is saying, is this a parallelogram if x equals 3? So what you have to do is plug in your value. So if we put 3 in here, we would have that this side equals 33. And here we would have 30 plus 3 equals 33. So we know that these two sides are congruent, but in order for it to be a parallelogram, both sides, both pairs of sides would have to be congruent. So we have to plug it into these as well. So if I plug my 3 in here, we'd have 32. And over here, we'd have 12 plus 8 equals 20. So we know that this pair of sides is not congruent. Since both pairs of opposite sides are not congruent, is this a parallelogram if x equals 3? And your answer should be no. So we're just going to put no here. Then it says, if not, is there a value that would work? So now we need to take a look at it and say, is there any way that we could make this a parallelogram? So in order to do that, your first thing would be to check 11x, set that equal to the 10x plus 3. So if we took 11x and set that equal to the 10x plus 3, we can subtract the 10x off. So we're left with x equals 3. And then you check your second set of sides. So now we need to check our second set of numbers. So here we'll write 10x plus 2, and we're going to set that equal to 4x plus 8. So we can subtract our 4x off both sides, and I can take the 2 away from both sides, and we end up with 6x equals 6. Divide your 6 off, and we end up with x equals 1. So if this is x equals 1, and this would be x equals 3, the value there wouldn't work. So the answer again is no. So these dimensions right here could not create a parallelogram. Another thing you can do is check angles. Remember what I said in the previous slide, you can't check consecutive angles to determine if it makes a parallelogram or not. You have to check opposites. This one is asking, is this a parallelogram if x equals 10? So take your parallelogram and plug that in. So we would have up here, if we plug the 10 in here, we would have 15 times 10 would be 150, minus 17 would equal 133. So far we have one set of opposite angles that are congruent, and now we need to check the other set. So here we have, if we plug in our 10, 4 times 10 is 40, plus 7 would equal 47, and this is also 47. So we have another set of opposite angles that are congruent. And now we need to, so now that both of them are congruent, is this a parallelogram if x equals 10? And your answer should be yes, because both opposite angles are congruent. And here's your work to prove that, so you can show that the opposite angles are congruent. You can also check the diagonals, which means if this was a parallelogram, then this diagonal side would have to be congruent with this diagonal side. So it's asking if it's a parallelogram. Would it be a parallelogram if x equals 5? So we'd have to plug in the 5 to see. So if we plug 5 in here, we'd have 4 times 5 is 20, minus 5 would be 15. And then if we plug the 5 in here, we'd have 5 times 2, which would equal 10, plus 3 would equal 13. Are these congruent? The answer would be no. So if x equals 5, is it a parallelogram? And the answer would be no. Then it says, if not, is there a value that would work? So again, we need to check. First of all, by taking 4x minus 5 and setting it equal to 2x plus 3. So we can do that over here. 4x minus 5 equals 2x plus 3. And then we're just going to try to solve for x. So I'm going to subtract 2x from each side and add my 5. So we end up with 2x equals 8. Divide off the 2, and you end up with x equals 4. Okay, so we know this side says 4, and then we need to check our second diagonals. So for this, we're going to check these two. So we'll put those right down here. X plus 2 equals 3x minus 6. So I'm going to take my x away from both sides and add my 6, and we end up with 8 equals 2x. So again, x equals 4. So is there a value that would work? The answer is yes. X equals 4. If x is 4, this would create a parallelogram. Another piece to it is just instead of solving, you just have to look at it and you have to go through your rules and figure out, is this a parallelogram? So in this picture right here, I have one pair of opposite sides congruent and that same side is parallel. So if you look back to the checklist that I gave you, so we'll go back here, you can see in all of these characteristics, one right here, if one pair of opposite sides is both parallel or is both congruent and parallel, so if we go back here, we can see that both these sides are congruent because they both have 8s and they're both parallel. So if they're both congruent and parallel, then this would be a parallelogram. So yes, this is a parallelogram based on those characteristics. In this one right here, this is 103 and this is 103. So that's one pair of opposite sides, opposite angles that are congruent. And then these are marked parallel. So if these are marked parallel, when you have two parallel lines cut by a transversal, so this would be what that would look like. Here's your two parallel lines cut by a transversal. If this is 103, then we know that these two sides would be supplementary, so they'd have to add up to 180. So we know that this side right here would be 77. So over here is the same thing. If this is 103, based on same side interior angles, we would have to have this at 77, this angle, and we would also have to have this one at 77. So based on same side interior angles, both pairs of opposite sides or opposite angles are congruent. So the answer to this, if this is a parallelogram, is yes, this would be a parallelogram based on that. Now in this last example right here, I have one pair of opposite angles that are marked congruent, but these sides are not marked parallel. So since these are not marked parallel, I cannot prove that these two add up to equal 180. So I have nothing parallel. I don't know anything about the two sides. I only know one set of opposite angles are congruent. So therefore I cannot assume that this is a parallelogram. So I'd have to say for this one, no.